Good evening, all. This is one of the first session of the series, and we are orienting on the BIM fundamentals. So, as an intro, this session is not about any particular software. This is more on the general BIM platforms and BIM fundamentals. So, moving ahead, the topics we would like to cover here is the BIM concept, a brief history of BIM, what are the benefits of BIM, what are the standards for the working of BIM, and the scope, field of work, and lastly, the future and the way forward. So, moving ahead, the BIM concept. So, as you know, BIM stands for Building Information Modeling. For the government tender purpose or more technical documents, it is also known as virtual building, building simulation, virtual design and construction, VDC, etc., etc. So basically, it deals with the drawings, 3D building views, walkthroughs, visualizations, calculations, and quantity takeoffs that are automatically derived from a 3D BIM model. So that is a more simpler version of like how we describe a BIM. But defining it in a more sophisticated, more technical manner, like the BIM steering committee for ISO standards have defined a modeling technology with associated set of tools and processes to produce, communicate, to analyze through the use of digital information models for completing the project construction lifecycle. So ISO is the platform, or ISO is the organization who actually controls the standards developed across the world. So they have been given this definition. So moving ahead, so BIM, or as we already discussed, it has a building component, information component, a modeling component, the softwares we use for the BIM. There is a design component, which is the basic input to the BIM. There is a planning component, which governs the allocation of resources, etc. The computer component, or the hard or the hardware associated with the BIM. So moving ahead, we will be discussing about the traditional and the BIM approach. In a general traditional approach, there will be so many players like the architects who designs, the general contractor, electrical engineer, project manager, structural engineers, owner, facility manager, fabricator, mechanical engineer. So there will be establishing a multiple set of communications across. As the picture depicts, there will be communications through and through between the, for example, architect to owner, architect to project manager, architect to structural engineer. So there will be a lot of the communication will be through email, or it can be verbal also. In between this communication, while establishing, there may be loss of information. So that is where the BIM approach finds good. So there will be a common platform, common common terminology, which we defined it as building information model, through which we communicate to the architect, the owner, the general contractor, electrical engineer, so that everyone is on same page. What I, as an architect, what I understand about the project, the design, that should be communicated to the structural engineer, the electrical engineer, mechanical engineer, etc. So that platform is actually the building information model. So moving ahead, so comparing the traditional approach to the BIM approach. So this is a graph representing the the uh, the designing in BIM, whereas the efforts taken for each section. For example, the traditional digital process, that is denoted in the green. So at the initial building concept stage, the effort will be much less. As we grow, or as we move forward, there will be a peak peak of the design stage where maximum effort is required and it gradually slows down. Whereas in BIM workflow, the effort will be little bit higher than the traditional approach, but that won't be as much as the traditional design approach. Comparing the cost versus cost versus BIM versus traditional approach, the initial cost of design while during the traditional stage will be much less, but it will be much higher when the project completes. In the case of BIM, the initial stages will be initial cost of the approach will be much higher, but the project completes or the design as progress and project is executed, it will be much less. So maybe in an interview or something, maybe if you are attending a BIM for the position of a BIM, this may be a question. So we were discussing about what is BIM, the components of BIM, the traditional and the BIM approach. Uh, so in the case of a traditional approach, there will be multiple conversations between the players. While in the case of a BIM approach, there will be a central model through which the communication is established. So moving ahead, so just we were comparing the traditional efforts taken during the traditional approach and the BIM approach. The cost of design changes or the cost of BIM projects, that for the BIM it will be much lesser. The cost of the BIM execution will be much higher in the initial stage, and moving ahead it will shallows down. But in the traditional approach, it is the opposite. So regarding the history of BIM, so maybe we can divide the entire uh, BIM development into four levels, the level 0, 1, 2, 3. So in 1960s, Douglas C. Eaglebert described a future where the architects would interact with digital building models, foreshadowing the core principles of BIM. Maybe that is something we recognize it as the initial starting of BIM. So in the 70s and the 80s, the building description system, the BDS and the glide system by Chuck Eastman. So that was one way forward in the time. So moving ahead, so the initial 90s for the BIM level 0, it was CAD. Then it slowly progresses into the 2Ds and 3Ds in 2000s. In level BIM level 2, the BIM point solutions. Now we are at the 2020s with the building lifecycle management, BIM plus PLM platform in the 20s. So in the initial level 0, it was drawings which we focused on. In level 1 and 2, we focused on the models, objects, collaborations, etc. In the level 3, interoperable data, which can be holds good for so many other things. Regarding standards also, so in order to standardize the development of BIM, the BS standards were there, which finally now in the 2020s, IFCs and IFDs are the common standards which we use. So initially for the CAD, the output was in the papers. In 2D and 3D, the file system, the files libraries, and now we are into the integrated BIM services, mainly on the cloud platform. So moving ahead, so as I said, the 90s to 2000, it can be considered the dawn of 3D modeling, which is BIM 1, followed by BIM 0, which was the CAD. Then comes the BIM 1, the BIM 2 to present is more on the sustainability of the buildings, focus on life cycle assessment, other green practices. These are the keywords or catchwords which we saw nowadays. So now we are going into the BIM 3. So the section 3, benefits of BIM. So obviously it starts with the designing. So the program will be there for the design, the conceptual design, detailed design, analysis, documentation, fabrication, construction, logistics and for the construction, operations and maintenance, demolition, and again, in case if renovation is needed, renovation and program. So all these stages of project cycle BIM holds good. So it is involved with various software. So we may think like building information modeling. As you all know, BIM stands for building information modeling, but it is not a single software. There are group of softwares which it holds good for each of these stages of building life cycle. So moving ahead, so what are the benefits of BIM? So basically, as I said, in the 2020s, it is more onto the sustainable and the smart buildings, better energy emergency response in case of, for example, in case of fire, etc. Improved cost estimates, better insights into projects, better end results, less risk and wastage, communication and collaboration with the various stakeholders, reduce cost and wastage, maximum manpower efficiency, and above all, the final output can be used for the asset management, for maintenance and operations. So for example, a metro project or a metro rail project. It is so complicated that it has to, after the construction of the building, the metro stations, it has to run for another 100 years. So how do you manage that? Maybe at the initial stage, uh, an equipment that has a lifespan or have a lifespan like 20 years. So after 20 years, the person who maintains that equipment may not be in the roll call or may not be in the service. So after 20 years, how do you recognize that that equipment may be changed or maybe altered or maybe improved? So in that case, there should be an asset management uh, mechanism to that, where the BIM as a building information modeling gives you input like, yes, so it is 2045. You have to change this equipment for the smooth functioning of the system. So these are one of the, this is just an example to understand the asset management and the maintenance aspect of BIM. So moving ahead, so what are the major popular BIM softwares? So as I said, like, so basically we are more familiar with the design softwares like the Revit, Allplan, Magic, Rhinoceros, NovaPoint, etc. So there are other sectors which is collaboration. Generally, we go for the Triple Connect, Revit So, or BIM Sync. Building performance analysis is one sector where we go for the Sapphira, ANSYS, IES. For visualization purpose of the data, like as I said, for example, over a period of time, what is the number of how many times an equipment have been replaced? Whether are we getting the same life cycle as earlier? That kind of visualization or data visualization is envisaged through Data Studio and the other softwares. So regarding the management, facility management, clash detection, as you know, Solibri, the Navis work, etc. are used. For the, sorry, for the visualization purpose, we use Enscape, Lumion, VREX, etc. So these are some of the softwares which we can use for the various verticals within the discipline. So regarding the working concept, see, as I said, like this is a single concept file where everyone give the input of their respective discipline and which is taken forward, and it is the complete building model and all of its representations are included in the BIM file. The real architectural elements are used for modeling. Then the changes of model effect are related to the drawing. So basically, it is a single file concept. Everyone contributes to the single file, which is the input for so many other disciplines. Ultimately, For additional materials, rendering, animation, quality takes off, etc. schedules, etc. It is used. So, so while working the concept, so there is an internal collaboration as well as the external collaboration. So the central file contains the complete virtual building database. The team members work on local copies. Team members have dedicated workspaces. Team members send and receive changes regularly, which allows the effective manpower allocation. So ultimately, there will be a central model or the collaborated model, uh, which is interdisciplinary, which is given to the other disciplines for the input. So about the external collaboration, so that internally collaborated model is given to other, for example, the contractors, the quantity surveyors, the product manufacturers, engineers, building certifiers, the various other agencies in various formats. The general formats include IFC, or it can be in a AutoCAD drawing or PDF, XML, etc. So here the building model is the centrally derived, which is mainly by the internal collaboration that is finally given to the other parties or other stakeholders as inputs, and they further develop it. So as I said, like there are a lot of parties associated with the concept. A standard is written. So what are the BIM standards? So moving ahead, so there is uh, a standard required for dimensions. So you might have already seen this 3D stands for the shape, 4D for scheduling, 5D for estimation, 6D for sustainability, 7D for management, 8D for safety, 9D for linear construction, lean constructions, and 10D for prefabricated or industrialized construction. So maybe 8, 9, and 10 are something new. Up to 70, right now it is practicing in the industry. We are yet to or we are yet to develop more technologies associated with the D90 and 10D. Yeah, going ahead. In the earlier version, I have mentioned about the BIM dimensions. So there is a term called LOD or BIM level of development associated with the modeling. So LOD or level of development consists of two crucial components, like one is level of detail and the level of information. For example, in the LOD 100, we may describe it as a chair. In the 200, we describe it the, for example, the width, height, etc., etc. In the LOD 300, we may just like the, for example, the Herman Miller, the manufacturers, etc. In the construction, LOD 400 is more about the construction. It deals with the each and every parts of it, and LOD 500 is the as-built or the facility management phase. So basically, LOD is equal to the level of detail plus level of information, which ultimately is the building's model. So LOD 100, it's a pre-design phase. 200, it's a schematic design phase. 300, it's a design development stage. 350, maybe it's a kind of construction documentation, or GFC, you can say, good for construction stage. 400, again, it's the construction stages and the minor changes in the construction with respect to the contractors. LOD 500, it's the final as-built stage. So just a pictorial representation, for example, for architectural elements, a door may be represented in the 100 stage, LOD 100 stage maybe as like this. As you move ahead, the LOD 500, this will be with the all the details like the manufacturer, the lifespan, the color, texture, when it has to be repaired, all sort of things. For example, in the structure, it will be with the bar bending schedules. It will be with the structural, each and every elements of the structural element with much details at the 400 and the 500 stages. In the case of MEP also, so in the sorry, in the first stages like LOD 100 to 100 stages, it will be a simple line diagram. But when it moves to the 500, it will be with each nuts and bolts, showing the uh, real life uh, depiction of the equipment, the pipings, mechanical instruments, etc. So here comes the ISO standard. So international standards for described. So in the level 0, it is a CAD. In the level 1, we have already meant like it is 2D and 3D. The level 2 stands for the BIMs. And in the level 3, it is the life cycle management or the ISO BIM. So in the level 3, it is drawings, lines, arcs, etc. In level 1, it is models, which ultimately collaboration. In the level 3, interoperable data is generally considered as the BIM maturity levels, you can see. So ISO 19650 is one standard which we generally adopt for the execution of BIM. In the 19650 itself, the level 1 is concepts and principles. Level 2, it is the delivery phase of the assets. In level 3, 2020, it is operational phase of the assets. Security minded approach to information management is in the. So this is uh, this is a normal documented procedure or technical documented procedures which allows the a BIM professional to develop the model across the globe. So why ISO? As I said, like so it has to be standardized because see there are BIM professionals who works across the globe, across the timings. So a person working in USA, if he is transferring the BIM models to India and later to work on the same model. So both has to be under the same umbrella and same page. In order to do that, the ISO holds good. So there are much details into it. So I'm not going into the further details. So this is it's a kind of umbrella which takes care of the standards and the modeling criteria you can say. So what are the scope and field of work? So as you know, like BIM, so BIM has a lot of potential. So it can deal with the architecture, structure, MEP, the asset management, etc., etc. So architectural design, it can produce a lot of design alternatives. Design can check the constructability, the planning budget for it, material selection, etc. These are some of the uses in the architectural design. Moving ahead, the construction. So the documentation or the manpower input for the documentation is one of the critical element or the critical cost for the design stage. So, for example, if we are doing something, for if we are doing a plan, this is for the beginners. So many of you may be already aware of it. I'm just giving a glimpse. Like if you draw a plan in BIM software or in a Revit platform. So with adequate inputs that can be converted with minimum effort into 3Ds, we can take the details, schedules, sections, etc. So that is the beauty of the BIM. So it is all correlated and you can, so while changing the plan, you can envision that change in 3D also. That is one of the major advantages of using a BIM software. So while interiors, 3D visualizations and the photorealistic rendering is one of the uses. So, as I said, like in the 5Ds and 6Ds of BIM, so solar analysis, the shadow analysis, etc., are also taken care by BIM software. And whether are we getting, are we building the, or are we designing the buildings with in a sustainable manner? That is what the BIM softwares are capable of telling you. That is one of the recent development, not the recent, but it is on the way, or it's in the progress to define more sustainable buildings. Yes, by analyzing the sun path, the solar analysis, etc. etc. So while structural BIM modeling, you can obviously design the RCC buildings, the steel buildings. Uh, in the earlier, we used to take drawings, the bar bending drawings, etc. Much difficulty. Like a lot of inputs are required to get all those drawings, shop drawings, etc. What after the coming of the BIM software, especially the Tekla software, Tekla structures and all, like once the design is over, you can automatically generate the detailed drawings, etc. The bar bending schedules, etc. etc. So because development of detailed drawing is a laborious process, and uh, just like that is of uh, non-income generating task. If that can be put in that effort can be put it into other design aspects, it will be of great use. So where in that case, the BIM softwares, especially the Tekla, comes to use, and within a click of a button, you can generate the detailed drawings in structural BIM. Yeah. As I said, like the design analysis, once the design analysis is over, the rebar modeling, the ductile detailing, the ducts for the MEP, etc., the bar bending schedules, etc., can be easily generated with limited resources or limited resources. So, MEP service planning, yes. So earlier, while planning for a complicated building, just like a metro station, what happened is in just like the London Tube started operation in 1860s. So then, just to compare, there uh, the MEP services were planned on site to avoid the clash, because majority of the stations are underground. You don't just like the assumptions of clashes or the assumption of interaction between the various disciplines, it was very difficult to solve. Once with the application of microstations or Bentley softwares, which is used in the London Tube metro stations. So basically, the majority of this service planning can be taken up in the initial stage itself, so that there is less interaction with respect to the interdisciplinary coordination at the site. What does that mean? Basically, so interdisciplinary coordination at site means that is a hell lot of stuff. Like it is very difficult, and in order to arrive at a conclusion, it is very difficult. If that can be done at the pre-design stage or at the earlier concept stage, in the preliminary design itself, so that saves a lot of time, a lot of effort, a lot of money. So in this case, the MEP service planning, especially the HVACs in case of air conditioned buildings, so we can see it in the 3D. It's like these images are on the 3D itself. You can visualize it. That's the beauty of it. So whether the sprinklers are online, whether it is clashing with any beam or columns, etc., whether the plumbing lines are clashing with the electrical lines, whether the much needed buffer space between the plumbing and the electrical lines is there or not. Or those clash detection, which is the terminology which we use in the BIM field, can be done at uh, pre-design stage or before the starting of construction itself. so that minimum coordination is required at the site level. Also, suppose, see, while if it is not done at the before the site, if it is done at the site, there will be a lot of wastage also. For example, one guy will come and fit the sprinklers. The second guy will come up with the plumbing line, which will be clashing with the beam. So he doesn't have the space. So the sprinkler guy has to realign the sprinklers and the pipes. So ultimately, that is a lot of rework, which is a wastage to it. So a BIM or the BIM platform allows us to save money, save time, and avoids the wastage also. Yeah. So as I said, the clash detection, it can be virtually seen whether any uh, clashes between the disciplines are happening, whether the plumbing line is clashing with uh, electrical line, sewage line is clashing with the electrical line, etc., etc. So generally, what we do is for each discipline, there will be separate models, which is done at the disciplinary level, then taken it into the common central model where we go for the clash detection. Yeah, moving ahead. So clash detection itself, it can be a hard clash, like beams clashing with the walls, beam clashing with the beams, etc. Or it can be a soft clash between sufficient geometric tolerances are not given. That can be also a soft clash. The workflow clash, or the third clash, which can be like uh, a workflow clash results in from the inconsistent or conflicting building information. For example, an HVAC maintenance schedule that does not align with the scheduled delivery of spare parts. For example, we stage the construction sequences such that clash between the interdisciplinaries and sufficient time is there and for the fitting, etc. But some cases, when it is not properly planned, due to lapse from any particular team, that particular equipment may not come to the site, etc. So, which may be a governing factor in deciding the total progress of the project, etc. So all these can be avoided. This kind of workflow clash can be avoided by using the BIM platform. So future and way forward. So we have defined the BIM level 0, BIM level 1, 2, 3. So as I said, like the future of BIM is always bright. So we are just at the starting of J curve. We are just starting the architecture, the structure is slowly filling up, but the MEP is far, the MEP or the services are yet to move lot or progress a lot of way. So there are a lot of potential to it, and there are opportunities like anything which can be read. So by the side of it, now it is the AI and the machine learning. So there is an AI part, artificial intelligence part, which helps us or which reduces the time cost into the BIM modeling itself. So many of the tasks in the BIM modeling itself can be ultimately AI powered, and it can design improved can be solved using the machine learning. For example, there are apps available for the development of 3Ds. If you give a maybe a wireframe image of some building, you can develop the 3, 4 virtual images with properly rendered images of different types. For example, it can be a classical, it can be a modern building, it can be a new trans building, etc. That can be generated using the apps. So, which ultimately is a work of an artificial intelligence. So, BIM 3 is definitely characterized by the artificial intelligence. Uh, Obviously, it can be cloud-based platforms so that across the globe it can be work. The tools and the softwares can be work. The platform can be used, and which ultimately uh, will be dynamic and that intelligent tool that can optimize design, construction, and facility management. Yeah. So at the last stage, so as BIM continues to evolve, it promises to shape the future of the built environment, creating smarter, greener, and more livable space for generations to come. So with this, I am just concluding. Yeah, thank you. Uh, I have touched upon the basic fundamentals of BIM. There are more, just like more topics to be elaborated, like common data environment, CDE it is called. For example, the Autodesk collaboration platform. So that is one major topic, but it requires a lot of time to deliberate upon. Then the software is like Dynamo, which helps us in the uh, BIM tools, especially in the Revit. The Grasshopper is another tool which actually uh, kind of uh, help us in reducing the time saving for modeling, etc.